Okay, these are from section 5.3 in the pre-calculus textbook. We're looking at number 15 and 17. The assignment in 5.3, it's on the side board. Let me see if I can find it. 3 to 45 odds. So we're doing 3 to 45 odds. The previous video had some of the early ones. Okay, to do these questions, you have to recognize this as an identity. 2 sine theta cosine theta is equal to the sine of 2 theta. Now, what happens to be theta? 15. And when you multiply 2 times 15, you get an angle that is on our trig table. And the sine of 30 degrees is 1/2. Okay, if you did not see it that way, this equals the sine of 2 theta. So that means the sine of 2 times 15 degrees. So that turns it into the sine of 30 degrees, which we do know is 1/2. Now this one over here matches a different identity. Cosine squared minus sine squared. Anybody know the identity for this one? Cosine of 2 theta. So I want cosine of 2 times what's the theta in this? 75. So that makes it into cosine of 150 degrees. Where is 150 degrees? What's its reference angle and everything else? 150 degrees is how much less than 180? So that's my reference angle. I look up the cosine of 30 degrees, and I believe it's radical 3 over 2. And then in this quadrant, it's negative, positive, cosine, sine. So it should be what? Negative. So there's 15 and 17. Okay, here's 15 and 17. If I go to the next group of problems, it is an identity. And then when you get to an identity, you're trying to verify the identity. So what is the, let's see what we can do here. Sine of 2 theta. Do we know what that equals? I believe it's 2 sine theta cosine theta. Now hang on, I'm going to try and match. Okay, I used an identity. I changed sine of 2 theta into this. I know it's over 1, but I know I need to make the denominator into this. So how do I do it? I multiply by this fancy form of 1. Now my denominator is 1 plus tangent squared, which is a denominator that I desire. Now on top, let's see what happens. What's 2 sine theta cosine theta times 1? That's going to give me 2 sine theta cosine theta, right? Plus, when you distribute here, you get 2 sine theta cosine theta times what? Tangent squared, which what is tangent? Is it sine over cosine? And they're squared because they're squared, as it's squared. So, let's see. 2 sine theta cosine theta plus, what's going to happen here? You're going to get 2 on top. You're going to get a sine to the third, aren't you? Sine squared times that sine. And one of the cosines will cancel, leaving you a cosine on the bottom, right? And again, this is all over this. I was just working in the numerator.
Oh, okay. All right.
So now I'll bring it up. I'm not sure this is the most efficient way, but again, we need to try and see what we can do. 2 sine theta cosine theta plus, what can we call this? Let's see if we can turn this into a tangent somehow. Why do I want it into a tangent? Because that's what's on top. So, could it be, just bear with me, could it be 2 sine theta over cosine theta. That would be 2 tangent, wouldn't it? Times what? Because I need to have, a sine squared? I need a sine cubed, so I think it would be times sine squared. And again, this is all over 1 plus tangent. Now, how do I get a common denominator on top?
Isn't it tangent squared?
Bottom, I believe it is tangent squared. You're right. But how can I make all of these have a denominator of cosine? Could I multiply by cosine over cosine? So let's do that right here, but only on the top. So let's try cosine over cosine. What would that make the numerator? 2 sine theta cosine squared theta all over cosine theta plus 2, could this be tangent theta? Hang on a second. I don't think I want to leave it like that. I want to leave it like 2 sine theta sine squared theta, and the whole thing over what? Cosine theta. Let me just look at this a moment. Hang on 1 second. I just need to write this out, and then we'll look. At this point, I'm going to factor out a 2 sine over cosine out of both of these. If I take the 2 sine over cosine out, that leaves me with cosine squared plus over here sine squared. I know that sine squared plus cosine squared is 1. So do you agree that this right here really is just times 1? And what is sine over cosine? So I think right now I have 2 tangent over 1 plus tangent squared. And notice that's what we wanted to make it match. The answer is your work. However, I want to see how you get to it. There might be a more direct way. Please let me know if you find one. Okay, let's take a look at this one. This one I think you'll find is another identity, but I don't believe it'll be quite as hard. Please watch. Do you know how to square a binomial? You square the first, you square the last, you multiply this and double it. So 2 sine cosine. And I'm basically there. What is sine squared plus cosine squared? Plus 2 sine cosine. And that matches? No. Let's see what we have here. This doesn't match yet because I haven't applied my identity. 2 sine cosine is sine of 2 theta. Now I believe it does match. There's an alternate problem to the right over here. I just wanted to see if anybody could see a slightly different one. It's almost the same as 25. Anyway, after 25, we're going to try this one, which is a sine to the 4th. And if we read the instructions, it's going to say, use the power reducing formulas to rewrite each expression as an equivalent expression that does not contain powers of trigonometric functions greater than 1. In other words, I need to get that 4th power down to a power of 1. So, using the identity. So I'm going to write 6 sine squared times sine squared. Is that still sine to the 4th? Okay. 6. Does anybody know the rule for sine squared? 1 minus cosine 2x all over 2. I'm sorry, yep. And the other one is also sine squared. 1 minus cosine 2x all over 2. If it was cosine squared, it'd be 1 plus cosine 2x all over 2. So you get 6/4 or 3/2 1 minus cosine of 2x, and you wanted it quantity squared, right? So how do you square this binomial? Square the first, twice the product, and square the last, right? So would that be cosine squared of 2x? 3/2, 1 minus 2 cosine 2x, plus, do we have a rule for this one? For cosine squared, it's almost the same as the sine squared, but it has a plus. So, let's clean all this up. If you don't mind, I'm going to distribute. 3/2 times 1 is 3/2. 3/2 times 2 gives me a 3. 3/2 times 1/2 makes a 3/4. And I'm wrong, this should be cosine of 4x, shouldn't it? If I double the angle, 2x, I believe this should be 4x. Now I think I have it down so that there's no power of a trig function greater than 1. Let me check their answer. If I were to distribute...
In the gymnasium, I'm sorry. And don't forget to continue to bring in your items for personalization, non-perishable items, and household items that have been on the list.
Okay, this is 6/4
Red kindness.
plus 3/4. 6/4 plus 3/4 is
So again,
9/4.
wish you all the very best and have a safe and happy weekend for everyone. Thank you.
And this is a simplified version of the one above, but I think now I match their answer, right? Anyway, I hope these help. Good luck.